Number 1 gives us a logarithmic expression, and it asks us how we would say this expression in words. So you say it is the log base 3 of 81. So log base and then the little number of the bigger number. So log base 3 of 81. And then it wants us to evaluate this expression. So remember that this means what number gives us back 81, okay, when we have a base of 3. What exponent do we put on 3 to get back 81 is really what this logarithm is asking. And this is 3 to the 4th power is 81. So the answer to this is 4. Number 2, evaluate each expression. So log base 10 of 100 says what exponent on a 10 gives us 100. So 10 squared is 100. So the answer to this logarithm is 2. So what exponent on 100 would go back to 10? And so that's just this exponent, but the reciprocal of it. So 1/2. So 100 to the 1/2, or the square root of 100, gives us 10. So that's going to be 1/2 or 0.5. 3 to what power gives us 27? And that's 3 to the 3rd. So the answer to log base 3 of 27 is 3. So log base 27 to go to 3. So 27 to what power gives us 3? And so that's going to be 1/3 if we're reducing it back down to 3. So 1/3. Number 3, the amount of radioactive substance can be modeled by this equation. The equation models the amount of substance in milligrams, and that is remaining after T hours. So what is the initial amount of bacteria present? So that's 4,000 milligrams. Remember, we get that from this spot here, what times the factor. Write a logarithmic expression that represents when the population will be 100. So now we're knowing that we want this output here to be 100. So we're really looking at solving this expression here. And so we want to kind of get back to this. We want to isolate this exponent a bit here. So we're going to divide by 100, or sorry, we're going to divide by 1,000 first. So that's going to get us by 4,000. We're going to divide by 4,000 first, which is going to get us to 2 to the negative t. Okay, so you can reduce this to 1/40th. Then we have, to get back this exponent, now we could do a log. So this would be log base 2 of 140, saying what exponent gives us back 1/40th? And that's going to equal negative t, because that's what's in the exponent. So then we could just multiply both sides by -1, which would get us t. So t is going to equal negative log base 2 of 1/40th. Then part C says evaluate P of 24 and explain what it means in context. So here we're just going to go back to our original equation and plug 24 in. So P of 24 equals 4,000 times 2 to the negative 24. So then you can just type this in your calculator. So 4,000 times 2 to the negative 24. And we get back 0.00024 or 238. And this is the amount of substance remaining, right? So this is we have this much, okay, that's the kilograms of substance remaining after 24 hours or 1 day. So you have 0.000238 kilograms of substance remaining after 24 hours. Number 4, the population of a town is growing exponentially and can be modeled by this equation. The population is measured in millions and the time is measured in years since 2000. Select all true statements. So, A, the population of the city in 2000, so the initial population is 31 million. So we see that we have 3.1 here. So this is actually 3.1 million, which is 3,100,000, not 31 million. So A would be false. The population is growing by 2.5% each year. And so we can see this up in the exponent here. We have 0.025 is the percent of growth, not the growth factor, but the percent of growth. So then we can times this by 100, and that will get us 2.5%. So part B is true. The population in 2030 is 6.56 thousand. Okay, so if we plug in 30, because this is 2030, so that's going to be 30 years since 2000. So if we look at P of 30 and we plug this into our calculator, 3.1 times e to the 0.025 times 30, okay, you are going to get back 6.56, but that is not in thousands, right? So P of 30 does equal 6.56, but it's in millions, not thousands. So part C is false because of that word thousand. D, the growth factor of the population per year is approximately 1.025. So growth factor is going to be the e to the 0.025. So plug that into your calculator to get it to be a decimal. So e to the 0.025 is equal to 1.0253. So approximately 1.025 is true. Then E, the expression ln of 10 divided by 3.1 divided by 0.25 represents when it'll be 10 million. So we would plug 10 million in for P of t. Then we have 3.1 e to the 0.025 t. So we can divide by 3.1. And then to get this exponent back, we would do the natural log of that 10 divided by 3.1 would equal this exponent. And then we would divide by, and that's 0.025. So then we would divide by that 0.025 to get our t by itself. So then t would equal the natural log of 10 divided by 3.1 and then divided by 0.025. So this would be true. Number 5, complete this table. So we see that this is our x value and the bottom is 10 to the x. So this represents our exponent, and then we're in the bottom going to be writing it as 10 to the x. So if our exponent is negative k, then this is going to be 10 to the negative k power, which we could also write as 1 over 10 to the positive k if we wanted to bring it down to the denominator. Here we can see that this is tenth, hundredth, thousandth, 10 thousandths. So this is 1/10,000th. And so we can see that this is 1 over 10 to the 4th power. So our exponent here was -4. If our exponent is -1/3, so 10 to the -1/3 power, you could also write that as 1 over 10 to the positive 1/3. You could also write this as 1 over the cube root of 10, since 1/3 power is the same as cube root. So all 3 of those would work. in that one. Next one, if our exponent is 0, 10 to the 0 power is just 1. So this is 10 to the 0, which would simplify to 1. If we have 1/5 power, so 10 to the 1/5, that's the same as the 5th root of 10. Cube root of 10 means that our exponent would have been 1/3. 10,000, so this is 10 to the 4th power, so our exponent would be 4. And if our exponent is m, then this is going to be 10 to the m power. Number 6, the equation 1 times 2 to the x represents the number of subscribers in thousands a social media influencer has on her platform X months after she started tracking it. Select all true statements. So log base 2 of 50 represents how many months it will take her to reach 500,000 subscribers. So remember, this is equal to the output. Okay. So 50,000, not 500,000. So this actually represents 50,000 subscribers, how long it'll take her to get 50,000 subscribers. The graph shows that 6 is a reasonable approximation for log base 3 of 400. So let's take a look here. So here's 400 and 400 hits here. That's at 6, okay, about 6. So this would be true. Part C, log base 2 of x equals y is the logarithmic form of this. And that's true because the base is 2 here. Okay, so log base 2 of a number is going to be the logarithmic form. The influencer will reach her first 100,000 subscribers shortly after 5 years. So again, we're going to look at the table here. We're going to look at 100 since this is in thousands. So here's 100 and it reaches there somewhere between 4 and 5. So this says shortly after 5 years. So that's not true. It's happening at about 4.5. And really this is in months. So 5 years is way too long. So it's happening about 4.5 months. Part E, the graph shows 6.4 is a reasonable approximation for log base 3 of 500. So let's take a look at 500 as our output. So 500 is here. Okay, touches the graph going down here. So somewhere after 6, right? So between 6 and 7. So 6.4 months would be a reasonable approximation for that. And so then that means after about 6.4 months, she's going to be at 500,000 subscribers. Number 7, rewrite the logarithmic expression in exponential form. So we're going to take the base of the logarithm, 10, to what power gives us 1 million. So 10 to what power gives us 1 million. Here, remember that this base is e. So this is going to be e to the x equals e to the 4th because that e to the 4th was plugged in there. So e to the x equals e to the 4th. Next one, so this one is going to be 8 to the negative 2 is equal to x. Part D, natural log has a base of e, so this is going to be e to the 12th power equals that input of x. And then the last one has a base of 10, so 10 to the 7th power is going to be equal to x. Number 9, here's the graph of a logarithmic function. What is the base of the logarithm and how do you know? So you want to try and look for an ordered pair or like a crosshair where these are equal. And so I can see one right here. So I see that 3, okay, is getting popped back out for 1,000. So then I know that I need 3 to be the exponent. Okay, and so what base would give me an exponent of 3 with 1,000? So 1,000 is equal to 10 to the third, so I know that 10 is the base. So find the missing points on the graph. So the following points are on the graph, but there's a missing coordinate. So we know these are on this graph. So fill in the missing coordinate here. So basically, this is the exponent, or this is the output, right? The exponent on 10. Okay, so if the exponent on 10 is 0, okay, what is the output? And that's going to be 1. So 10 to the 0 power is 1. For 100,000, so 100,000 is 10 to the 5th power. So the exponent kicking back out on the 10 here is 5. And then the exponent here is 1/2. So 10 to the 1/2 is what? And you could put that in here. You could put square root 10. Okay, you could put 10 to the 1/2. You could actually figure out the decimal version of that as well if you wanted to. I like to not use decimals because then I have to use my calculator. But 3.16 you could have put there as well. Number 9, solve each equation. So we want to isolate this base here. So we're going to divide by 4 first. So we get 10 to the x equals 100,000. And now we can write 100,000 as a base 10, right? So 10 to the x. So 100,000 is 10 to the 5th. So then x equals 5. B, so let's divide by 5 first. So we get 10 to the 6y equals 7,000. So now we're going to have to do a logarithm. So we've got this base 10. So we want to say log base 10 of 7,000 is equal to this exponent. So then we would just divide by 6 here. So we'd have y equals whatever log base 10 of 7,000 is divided by 6. And so then you could type this into your calculator and you would get the log base 10 of 7,000 is 3.84, and then divide by 6 and you would get 0.64 approximately. And then you can always plug this back in here to make sure that you didn't do something wrong. So you get back approximately 3,500. All right, so then this one, to get rid of this 3, we're going to divide by 3. And really, instead of dividing, I'm going to say multiplying by a third since this is a fraction. So let's do multiply by a third. So then we're going to have 2 to the x, and then these 3's will cancel, so we'll get 1/8. And then we know that 8 is a power of 2, okay, because 8 is 2 to the 3rd power. So 2 times 2 is 4 times 2 is 8. So then we know that this exponent would be -3 because 1 over 2 to the 3rd is the same as 2 to the -3. So then x equals -3. All right, then this one we'll divide by 3. So we get e to the x equals 5. So then the natural log has a base e, so we can just do the natural log of 5 should kick back that exponent. So natural log of 5 you could leave as your answer, or you could type that in your calculator and get 1.609. And then again, you could plug that into here to make sure it equals about out to 15. Number 10, the number of subscribers in hundreds of influencer A can be modeled by this equation. And influencer B can be modeled by this equation. In both equations, M is the number of months since the subscribers were first measured. So label which graph represents each influencer. So in both equations, we can look at the initial amount. So this 1,500, right? And this 1,000, or 1,000. So 1,500 and 1,000. But we can see that influencer A will be the one that started lower. So we can look here and we see that this equation here started lower. So this line, okay, which then pops above here. So this is influencer A. Or sorry, yes, influencer A started lower. And then influencer B here started higher, and then they cross. So then this kind of bottom one here is influencer B. So I'm going to erase this so that we can look at these graphs. But influencer A is this one here, okay, that dips below. Influencer B started higher and then dips below as we go up. So the point where the two graphs intersect has a y-coordinate of 75.9. So this point right here has a y-coordinate of 75.9. What does this mean about the situation? Okay, so this is where both subscribers or both influencers have the same amount of subscribers. And it's 75.900, okay, which is really 75,900. And so both influencers have that at the same amount of time. So this is how many months until they both have the same subscribers. So then let's figure out how many months it is for A. So let's plug in 75.9 equals 10 times e to the 0.075 m. So we're going to divide by 10, right? And then do the natural log. So if we divide by 10, we get 7.59 equals e to the 0.075 m. So then the natural log of 7.59 is equal to 0.0. So 0.075 m. So then we'll divide by 0.075. So take the natural log of 7.59, divide that. Okay, so that's 2.02. So this right here is like 2.0268 divided by 0.075, and you get m equals 27.02. So 27 months. So now without solving, what will the value of, and this should say m, what will the value of m be for influencer B? So what will the value of m be? Well, m will equal 27 because they're the same point on the graph. So they're the exact same ordered pair. So if we know for influencer A it's 27, then we know for influencer B it's going to be 27 as well.